Assalamu alaikum. In this video, we will model a RC girder bridge with a single span, which length is 10 feet and width is 4 feet. Here is the dimensions of the components of the bridge. This bridge supports a total 2 lanes of traffic. Lanes will be loaded for vehicles and lane loads. For this specific model in sap2000, we will design according to AASHTO LRFD code for live load distribution factors. The live load distribution factors affect how the shear and the moment is distributed in the girder. In AASHTO LRFD code, the model may be either be a spine or use area object, but it should have only a single lane loaded, which is in this case a standard in the model. Now let's get started.
At first, we will start a new model. File, new model. The parameters will be in feet, inch and Fahrenheit. We will select grid only. In order to do bridge design, at first layout lines or grid lines have to be provided. The grid lines defines the location of bridge object. Our bridge will be straight with no change in grade. Here, the number of grid lines in x direction will be 2 for setting the diagrams. In y direction, it will be 5 for setting girders and land loads. In z direction, it will be 1. Here, the grid spacing will be 120 inch or 10 feet in x direction. In y direction, it will be 12 inch and for z direction, it is 1 feet. Now comes the materials. We will define additional material properties. For that, we will add a new material, which name will be concrete. Material type will be concrete. Here, the specified concrete compressive strength will be 3.5 kSi. We will use this material for all components of the bridge. Okay. Now we will define the girder. Section property, frame section. Add new property. Girder will be a concrete rectangular section. Name will be girder. We will switch the material with concrete. Depth will be 13 inch and width will be 6 inch. Here the concrete reinforcement will be for beam with clear cover in top 1.5 inch and in bottom 1.5 inch. The reinforcement will be of grade 6 deeper. Okay. In the same way, we will also define the diagrams. Concrete rectangular section. Diagram. Material will be concrete. Depth will be 10 inch and width will be 6 inch. Concrete reinforcement beam 1.5 inch clear cover. Here we will add also a new property of concrete section of 1 inch by 1 inch dimension for defining the land loads. Because without frames we cannot provide land loads. Material will be concrete reinforcement will be Now we will define depth. Section property, area section, attribute section, depth. Type will be shell thin. The material will be concrete. Membrane thickness will be 5 inch and bending will be 4 inch. Okay. Now I will draw the components of the bridge. At first, the girder. In our bridge, we have two girders at this grid line and at this grid line. Then the diaphragm. Now I will provide the frame where I want to provide the land load. So now I will look for these two frames number so that I can provide it in the defining of the path. So these two frames number is 5 and 6. Now I will provide the deck. Now the drawing is complete. So we can see the extrude view. Here is the extrude view of the bridge. Then we will define the moving load. At first, the path. Add new path. For path 1, the frame number is 5. Add. For path 2, the frame number is 6. Add. Then moving load, vehicles. Add vehicles. The load length type will be fixed. Here the axle load will be 3 kg for our bridge and the vehicle will fully remain in path. Now we will define the load vehicle classes. The load cases. For dead load, the load case type will be linear static. So we have to define moving load here. Add new load case. Load case type will be moving load. Here everything will be given the same. And load case name will be moving load. Here we can see that we have defined path 1 and path 2. Which is already shown here. So here, now the load arrangement over this bridge. So we will be able to run the model now. So I am now going to run the model. The model will not be included here. Run now. So now I am going to design the bridge. Design, concrete frame design, start design. Here our console is with girder, diaphragms and deck, not the frames which I was provided for the path. So here we can see that all these components are safe. We can also design it by SFT and BMD values which we can get from this SAP model. From show forces, frame forces, moment 3.3, show values on diagram. Okay, we have to check exit plan. Here we can see that the maximum moment is 58.86 cubic inch, and the maximum shear will be shear to 1.9 cubic. That's all. Thank you all for listening me.